Here's a story from Quartz. A theory that challenges Newton's and Einstein's gravity and nixes dark matter passed its first test. I'm Suzanne D., and you are listening to Newsbeat Radio. Margot Brouwer of Leiden University is brave, and you need to be, if you're challenging Albert Einstein and Isaac Newton in one fell swoop. Brouwer and her colleagues believe that the laws of gravity, as determined by Newton and further expanded by Einstein's theory of relativity, are not quite correct. If she isn't proven wrong, it wouldn't just make the geniuses turn in their graves, but it would also render useless the need for dark matter. To understand how, let's go back to high school physics. Newton taught us that gravity is the force that bounds the Earth to the Sun to the Milky Way, and so on. Einstein taught us that gravity is so powerful that it doesn't just hold masses together, but it does so while bending space-time. Both theories have passed most challenges thrown at them. Newton's laws, for instance, are still what we use to do sophisticated things like figuring where to shoot a rocket so that we can land a probe on a comet. And Einstein's laws are what we use every time we open the Maps app on our phone, which helps us locate ourselves using GPS technology. These gravitational models, however, could not explain the movements of galaxies based on their estimated mass. In fact, we were off by such a large margin that physicists figured there must be more matter in the universe, which we can't observe because it doesn't interact with light. They dubbed it dark matter, and it is the chink in the Newton-Einstein gravity armor that Brouwer is exploiting. Brouwer hasn't come up with a radical new theory from scratch. Instead, she is relying on work done by Erik Verlinde of the University of Amsterdam, and building on that by Mordechai Milgrom of the Weizmann Institute of Science. Their theoretical work suggests that the force of gravity is stronger and dies off more slowly than outlined by Newton and Einstein. To test this form of gravity, Brouwer analyzed data collected from distant galaxies that were observed between 2011 and 2015. Specifically, she focused on regions close to the visible disk of each galaxy. This region is known to undergo a phenomenon called gravitational lensing, where the light from the galaxy being observed is bent. See Einstein's theory. Because of the gravitational pull of distant galaxies. When that observed data is checked against Newton-Einstein's predictions, physicists have to introduce dark matter and tweak certain parameters to ensure it's a perfect fit. Verlinde's model of gravity doesn't fit the data perfectly, but it does fit without the need for dark matter or any tweaking. That's essentially what Brouwer has explained in a new study to be published in the monthly notices of the Royal Astronomical Society. Many physicists are skeptical of her findings. They may have fatal flaws that have not yet been caught. Either way, it will take much more than one study to force a rethink of Newton and Einstein's work. But the concept of dark matter doesn't sit well with many physicists either. The idea was first introduced by Fritz Zwicky in the 1930s and further strengthened by the work of Vera Rubin, who recently passed away, in the 1980s. But the research is short on detail. Even though there is a lot of indirect evidence for dark matter's presence, we have yet to find a way of directly probing it, and thus don't even know what it's made of.